Good afternoon, selamat siang from Terengganu, Malaysia, and also from Sydney, Australia. We are now back on our regional dialogues on data, finance, and governance for sustainable ocean development. In this today's session, we will discuss about from risk to resilience, how to integrating disaster risk into ocean accounts, and also blue finance. So ocean economies are among the most disaster exposed on the planet. We have floods, cyclones, storm surges, and coastal erosion that already costing our coastal communities and tourism economies billions every year. So what's less understood for us is that the data describing this exposure is largely disconnected from the accounting framework and also financial instruments that shape how ocean economies get managed and invested in. So that disconnect is a translation problems. Coastal hazard science has come a long way. We have high resolution search models, morphodynamic monitoring, and operational forecasting. But it produced as a research grade in formats and scales that maybe don't map into what our national accounts need and what finance ministries need, what a bond prospectus and our investment needs. The data exists, but the pathway from data to decisions does not exist. So for the hard question probably is how this science tells us today what we can do to inform the investment frameworks and also the our ocean accounting and blue finance, how we integrate this into our ocean accounting frameworks and to inform our disaster risk and disaster management and also the mitigation action, in particular informing how we can finance the disaster and risk and management. So before I introduce our facilitator and expert, please allow me to describe our session today. So for your information, this session will be recorded on UNSW YouTube channel on Center for Sustainable Development Reform channel on YouTube. And there will be a question and answer after the presentation from our expert and facilitator. And I encourage you to drop your question and answers on the our question and answer or chat box. And I also invite you to, if you are practitioners in disaster and resilience or management and mitigation also, please put forward your reflection how you can integrate your data and your information into our ocean accounting framework and inform the blue finance or financial investment to reduce the risk and also increase our resilience to ocean and coastal disaster. So with that, I will invite Dr. Khaira Ismail from University of Malaysia, Terengganu, to as of our facilitator and to introduce our expert for this regional session. Dr. Khaira, the mic is yours.
Thank you, Mr. Yoga. Thank you for the opening. I think good afternoon, good day to everyone. And thank you for joining us for this session on from risk to resilience, integrating disaster risk into ocean accounts and blue finance. It's part of our monthly regional dialogue. And it is also my pleasure here to introduce our esteemed speaker, Professor Technologist Dr. Muhammad Fadzil Akhir. Before that, I'm Khaira Ismail from Universiti Malaysia Terengganu, part of the Blue Economy Advancement Center, and happy to have you all here with us today. So Prof. Fadzil is the Pro Vice-Chancellor for Strategy, Performance and Corporate at Universiti Malaysia Terengganu, and he is also his expertise as a physical oceanographer at the Institute of Oceanography and Environment, INOS, UMP. His research covers ocean circulation, coastal hydrodynamics, monsoon-driven currents, upwelling, beach morphodynamics, ocean forecasting, observation networks, and coastal erosion assessment, particularly in Malaysian waters and also the South China Sea. So for today's session, Prof. Fadzil will bring a very important perspective that is the foundation of disaster risk and also ocean resilience, begin with the ocean and coastal data itself. Before we can speak about risk-informed ocean accounts, resilience planning, or blue finance instruments, we need to understand what the science can tell us and what it cannot yet tell us, and how these data sets can be translated into decision-ready information. And I think we also need to see like what kind of data set and also the legitimacy of the data set itself, and if it's valid to be used for this resilient planning and also as a blue finance instrument. So with that, I'm very pleased to invite Prof. Fadzil to deliver his presentation. Prof, the floor is yours.
All right, thank you very much, Dr. Khaira. I think I need permission to share my screen.
Yeah, I think can Troy please help
Okay.
Prof. Fadzil for that? Yeah.
All right,
Okay.
thank you very much. Okay, so my talk today will be, I think it's a bit hard for me because I usually speak on the perspective of physical oceanography, ocean dynamics, especially on the ocean data. But I think that's the connecting points that allow me to speak here today because I'm going to talk about how coastal and ocean hazard data can be very useful and important for risk-informed resilience planning. But I think before we start, I just want to let us, every one of us, let have this thinking for a while. So if let's say I'm going to tell you that there's a coastal project with a very low climate risk and therefore suitable for huge investment, what evidence would convince you? Either you are investor or you are government officer working in the agencies that oversees all this coastal protection, or even you are a scientist. Because a few years back, there's a one development effort is being proposed to take place in our place in Terengganu, which is huge on the really in the coastal area. So usually most people will tell you that okay, we need to look at the what's impact that it will have, whether it's gonna cause you erosion, sea level protection, what's going to happen if this being built, and what about the marine biodiversity assessment? So what's going to happen to productivity or fish in those areas? So all of these products are derived from underlying ocean and coastal hazard data. So everything that you ask is basically ocean data. But I think the biggest question that we need to ask ourselves is there's two things. One, do we have those data? And second one is, do we really understand those data sets? Because even though you can plot, you can show if there's a danger or there's a limitations and some aspect of information from the data, do we really understand what is happening? Can we really put the data into a real context? So I think that's the biggest issue. Sometimes people will say that, okay, I think this is a good investment, or this is good for our local communities because the data is showing you this. But data can show you certain things, but the understandings and how you understand those data to frame into that context of whatever you want to do, I think it will be the most important things. All right. If you look at the there's a huge growing interest in terms of marine ecosystem nowadays. I think I'm proud to say that when I started as an oceanographer, nobody really cares about ocean or marine that much. If you talk about marine science or marine ecosystem, only a handful of people within your bubbles can talk about it. No other people really understand about marine ecosystem. They only know about if you say that you are from marine science or marine background, they will say, oh, you do fish. But nowadays, the growing interest has come along with huge amounts of attention, especially because of blue economy. They require lots of risk assessment in the coastal area, resilience planning, marine spatial plannings, as ESG especially. Now corporate sectors talks a lot about understanding marine area because they need to also incorporate ESG reporting into their reportings, blue financing, blue insurance, even ocean account. So all of these components that not much being done before are now actually pushing the idea of collecting more data, more information, and more input towards the area of marine, and especially in the oceans. I think this is the benefits that scientists are very happy about. But of course, it's still in the beginning stage. But I think it opens up a lot of opportunity for us to capture some important aspect of collecting new sets of data and understanding and get more inputs and understanding from those data sets. I think this is a good things to happen. Telling you about this is something related to what we do in university as well. I think we start to see lots of our graduates, filling in posts in corporate sectors, especially because of ESG reporting, for example, relating to blue financing, insurance. Before this, they are usually going into sectors like marine related agencies, or maybe maritime ports, or HSE. But nowadays, you start to see your graduates going into corporate sectors, sectors that force more into ESG reporting, investments in marine related or blue economy. So it's a very good prospect, and I see these things growing, and I think we have a good future in terms of collecting more data and understanding more about our ocean. All right, I have one story, very interesting story, but this story is actually I'm going to relate throughout my talk today. There's one place, small sandbar in near Redang Island. If you're not familiar, Redang Island is not far from our place in Terengganu, so it's a very famous tourist island. There's one sandbar formed in this island back in 2019. It was not there before, so that sandbar is so famous. If you type Little Maldives, Redang Island, in your TikTok or any your Facebook or your Instagram, you'll see this white sandbar became a tourist attraction. So if you go to Redang Island, so the boatman will say to you, you want to hop off to this Little Maldives to take some pictures. I saw even some wedding people having the wedding dresses, and taking pictures in literally just want to take picture on this Little Maldives. Nothing special about this, but it is a sandbar that sometimes during higher high tides it's basically under the water. But I think the things that I want to tell you is it actually formed in 2019 because of one tropical storm happenings in those areas, which is Pabuk. To give you some background, Malaysia is not far from equator region, so this is the place where tropical cyclones or tropical storm is not familiar with. So statistically speaking, you have maybe one tropical storm in 30 years. It's just like once in a while, something that you will never expect, probably once in your lifetime. But it did happen in 2019, and because of that, this sandbar formed in Redang Island. But actually, we only knew about that, months later. But what actually happened in the coastal area is a huge erosion. So on the right hand side is a place not far from my place. So there's a huge erosion happens along the coast. At that time, I think specifically in my not far from my home, the coastal area at that time lost, I think, 20 to 30 meter coastline. I mean towards the coast. So this affected almost like 2-3 kilometers of coastline. So it is a huge erosion. It never happened in overnight. Looking at that extent, so it is quite big. But I think we learned three things from these events. One is these extreme events become much more frequent. The effect is even getting even stronger and stronger. So one event can actually give you something like a season of monsoon is giving you. So 3 months of monsoon doesn't provide you with loss of 20 or 30 meters of coast, but only one event can do that. So that's the extent of the extreme events. And the third thing is because we don't have much information or any specific equipments being installed along the coast, we don't know much about what is actually happening, because we can see it's happening, but we don't understand how what is the impact through sets of data. So what we can do is we can only observe global data or regional data sets coming from maybe meteorological or atmospheric data. But what actually happened in those coastline, we don't actually know up until now. So this should give us some perspective that even though you see it's happening, you don't really understand it if you don't have proper data sets. So why hazard data matters? I believe that there's three major things that why we really need this kind of data sets. So what hazard exists? So we really need to know in your area or in specific areas what actually the hazards that exist. Some hazard exist because of pollution. Some area because of erosion. It can be sea level rise in certain areas, and even in certain places you thought that tsunami might not be a risk, but it can be a risk because if you look into the data sets properly, you could be it could be a risk in your place. Take for example during the Aceh tsunami. We thought that Malaysia is not a risk for tsunami, but it did happen, and I think more than 70 lives was affected at that time. How often that they occur? So I think this is also important because they sometimes it can occur once every 10 years, one in 50 years, and one in 100 years. So that's why most of our analysis or analytical tools that we used before, usually we look into this kind of time frame. So, but maybe we need to have a new sets of time frame because of much more frequency of certain things happens nowadays. And so El Nino. Previously, we thought it's like 5 to 7 years occurrence, but now it can be back to back years. So that's even a new challenge to scientists to really understand what actually happens and how it happens. Extreme events in 1 year, sometimes it can happen once. Usually previously it's like once every 3 or 4 years, but nowadays it can happen 2 extreme events in one season. So this is all understanding on how often this should really understand about the hazard data. I think the most important thing is who or what it exposed to. So all of these hazard data must be a point to certain things that either is affecting ports or facilities or infrastructures, or maybe affecting economics of fisheries, or maybe directly to coastal communities. So this is why hazard data matters, because of we really need to understand and to put into context on, in the end, even though you have data sets, so you really need to understand how it goes to a specific people or aspect or sectors that is going to affected by the hazard data. I do lots of numerical modelings and also ocean forecasting. So I can basically tell you that what is coastal what is ocean and coastal hazard data really means, and what does it mean by coastal and hazard data. It is this kind of data set should answer few things. So otherwise it doesn't mean anything. So this data should explain to you at least what is happening. Some data only can tell you to that extent, but if you have some additional data, it can provide you with more answer, like what has happened. What is happening is usually a nowcast or short-term forecast. So it's basically give you some perspective of what going to happen, like 6 hours in one day. But what has happened sometimes can trace you back at historical data sets. So if you have more historical data, usually you can understand more. I think this is where ocean data management becomes even more important. And of course, by understanding what is happening, what has happened, usually we can deduce into what could happen next. So events like ENSO, El Nino, La Nina is a snapshot that sometimes can give you perspective on what's going to happen if this kind of things would be a norm. So that will basically give you a perspective of a climate, how climate change will take effect. And what may happen in the future. So this is basically a prediction that we hope that we can provide with a better certainties about what's going to happen, next 30 years, mid-centuries or end of centuries. So this is the terms that climate scientists always talk about. So they try to figure out what more can we understand about these long-term projections. So all of that require basic understanding of what is happening, what has happened, and what could happen in the short time frame. And sometimes I think one of the big challenge that we I think based on my experience as a physical oceanographer, so to put into perspective or to be more presentable in terms of our data sets. Sometimes we thought our data is very important, but wait until you talk to policymakers about your data. So sometimes they just don't understand what it's all about, and they couldn't make sense what's the data, why the data is so important. I think one thing is important to us is usually for the scientists is to make data more presentable so that people can understand better. And sometimes just a good visualization can make sense to them. So I think many policymakers think hazard data means just map, but map is only the final product. So what you need is observation data, historical data sets, how you make a comparison and how you make sense of out of this information, and then you make numerical models. Some people say that numerical models. So what it based on? Is it based on data you collected, or they just want to make sure that because when we say that numerical models is just using computers, so they said, "Oh, how come the data is good?" So of course we've gone through lots of this rigorous analysis and everything. So we don't want to dive into it when we explain all of these things to other people. But what we should do is to make sure that all of this data makes sense by putting into context on how this is going to affect certain things in specific things that you are talking about at that particular time. So numerical models data, ocean forecast, climate projection is all what it is now become a very important tools because people nowadays, sometimes when we talk with certain agencies, they wanted to know about what's going to happen next week, what's going to happen during next monsoon season. But some people want to know what's going to happen next 50 years, what's going to happen next 60 years. So I think that's what makes this hazard data become even more important nowadays. What hazard data can actually tell us? All right. So hazard data can estimate probability. So everything is about this kind of hazard data is a probability data. So it gives you some probability so that you can make some adjustment or you can calculate better ocean accounting, for example. So at the same time, you also can identify hotspots. So usually when we talk about localized data, usually we prefer to have hotspots, especially when you talk about pollution, when you talk about marine heat waves, some area that will be affected more than other areas. So this is hotspots that can capture a very important scenario of a certain area. Hazard data can also estimate future exposure. So it provides you with what are you exposed to. So if before this we thought that we are not exposed to tsunami or we are not exposed to tropical storm, now our data sets shows you that this is the kind of exposure that you will have with this kind of information and data that we've been studied before. Hazard data supports financial decision making, of course. So we hope that more data being collected can be treated as a hazard data that can be used properly to, making a better decision making, especially to support the, financial aspect of it. Hazard data cannot predict the future exactly. So this is what we should know. We cannot, rely too much on hazard data by expecting it to, behave exactly on the data. Sometimes what happening in the environment is totally different things. But this kind of you cannot eliminate uncertainties. There is always an uncertainties in data sets, because even though if you have 10 years of data sets in one particular area, try to understand coastal erosion or coral bleaching events, for example, you're still being exposed to some certain uncertainties, because based on our experience, every time take for example extreme events, even for El Nino, every time El Nino happens, we always caught by surprise on certain environmental effects affected by El Nino. Sometimes it affect northern part of our coral area. Sometimes it affect southern part of the coral area. Sometimes it affect central parts of east coast in Malaysia of the coral area. So every El Nino events doesn't provide you with a certain pattern or but you can say that it does affect you, but the area that it's affecting is totally uncertain, so we don't actually know. So hazard data is only as good as the observation. So what you observe is what's happening at that particular area, that particular time. Sometimes it's not going to happen again similarly to what happened in those areas. Hazard data does not equal risk. So hazard data is just like giving you perspective on exposure and vulnerability of those areas. I think previously there's lots of big development, usually especially oil and gas, do lots of environmental sustainability index. I think ESI. I think this kind of index is good because it provides you with some exposure of certain area with a bit of certainty. So if let's say there's oil spill happens, so which area will be affected with a certain kind of environment. So if mangrove area, so how it will be affected, what kind of effect it will have. If there's a turtle landing area, it is a bit different, but it gives you a bit more perspective on how this vulnerability and risk is being exposed in those areas. So of course, severe storm in an uninhabited area may have very low risk compared to a very moderate storm in the populated area. So that's how we wanted to treat hazard data. So it should be has some context, especially when we talk about who's going to be affected or what is going to be affected by those hazard data. All right, I'm going to bring you to 3 case study, which is very interesting. I pick some of this case study based on some of the data sets that we have, and it happens in our region. So case study number 1, when typhoon did hit Malaysia. The reason I put up this kind of phrase is because we always thought that Malaysia is not the place where typhoon will build up or end up going to be affected our coastal area. But for the past 5 years, since Pabuk, I think 37 years, 2019, we faced, I think, more than 3 tropical storm within that 7 years. So statistically speaking, it's supposed to be only 1 every 30 years. So we are facing a very interesting phase of our human life, especially in the tropical area. So this Pabuk 2019, we are so blessed that just 6 months before Pabuk happened, we deploy one of our collaborative partnership, coastal ocean buoy, exactly about 70 kilometers away from the coast, not far from the oil platform, and Pabuk literally passed through this our buoy. So I think that's just amazing. So if you look at here, this is Pabuk. You can trace Pabuk from basically south of Filipina is developing and then developed at that time and then cross South China Sea. It came into a Terengganu coast oil platform and it moved slightly north towards Thailand. I think this is the period where you see this is drops in terms of pressure, atmospheric pressure. And you look at here, this is the numerical models that we set up, showing you the path of the Pabuk tropical storm. So this is the one that actually end up become develop bad coastal erosion and also the little Maldives I told you earlier. So it happens in 2019. 2025, just early last year, it is a huge coastal erosion happens along the coast. Some of the data sets that we try to map based on SSPs, the scenario using the IPCC scenario projections. So it does shows that the surface of wind speeds is become increasing and increasing for based on the projection for the next mid-century and late century. So this is actually a road along the coast, not far from my house, not far from UMT actually. So it collapsed almost the entire road, about 500 meters along the coast because of that particular event. And this is even, things get more even more interesting. Early last year, at the same time, but it doesn't happen in the East Coast. It happens in a very narrow channel of Malacca Straits. Tropical cyclone Senya, making I think it develops for a few days in the middle of slightly north near between the Strait of Malacca and Andaman Sea. These kind of things never happened before. It forms in the sea not far from Malaysia, and then it moves to Aceh, and then it turned back into Malaysia. So within that 3 days, there's lots of discussion about even Met Malaysia, provide lots of input. Everybody was really concerned about what's happening because it might hit Kuala Lumpur or Perak and Kuala Lumpur area. So, but it end up lost the energy to actually develop into a cyclone, and then it passed through the Peninsula Malaysia. But it never happened before in Malacca Strait. Malacca Strait doesn't have that water mass that can actually generate that amounts of heat and energy for a tropical cyclone to form, but it did form at that time. So this is the kind of uncertainties, some things that happens nowadays when you never expect it's going to happen. So let's go to case study number 2. Climate change threat is bigger than what we thought, especially in the equator area, in the tropical area, in Malaysia context. Some of the study that we did with my team under the long-term research grant, we call it Ocean Climate Change Study. So there's lots of study under that program. So one of my team, so we try to have a look at the mean sea surface temperature for mid-century, late century, and end of century. So it literally shows you that by end of the century, so we're going to have like 2.5 mean sea surface temperature average more than normal, which is it's so hard to tell you what is going to affect, but increase of 1 degree is hard enough to think about the effect of what we are facing now. I think what we are facing now is already reaching 1.5 degree from the average. So anything that is happening in terms of heat nowadays can easily affect our coral ecosystem. Bleaching can be quite a norm nowadays. So there's lots of things is happening because of climate change, sea level rise, we see rising, increase of marine heat wave. Marine heat wave is so important for coral ecosystem because it any hotspots in marine ecosystem heat wave can basically create you lots with a lots of bleaching. Dr. Kara, do I? Can you
Yeah.
give me 2 minutes? So I'm going to wrap this up. I have one more case study before I wrap up. Case study number 3, which is tsunami. All right. This is important things for us to really understand why hazard data is important. Take, for example, Malaysia, we always thought that before 2004, tsunami will never happen in Malaysia. And it never happened in Malaysia, but we start to understand that it affect Malaysia does affected by tsunami. So nowadays, I think just recently, tsunami that happened in Mindanao. So there's a warning came up to Tawau area. It is a threat to not only Malaysia, but it's a global threat. Banda Aceh tsunami is actually not a regional threat. Tsunami. It is a global tsunami. If you look at tidal data for the entire globe, every single tidal data did show some effect of this kind of tsunami is happening. So we learned a lot before. So there's lots of things that we never thought that we should have done before tsunami 2004, but now we are doing it. So there's lots of development in terms of early warning networks and tsunami buoy to provide us with lots of information and preparation. So I think that's all from me. The most important thing is in terms of this kind of data, better data means better decision. So when you talk about to any marine scientists or any oceanographers, we love to have better data, but for what we are doing now, for the interest of lots of sectors into marine data, so we need to understand that if we want to really understand about the risk, planning for a resilience in terms of economics, in terms of the coastal area, better data means better decision making in the future. So that's all from me. Thank you very much.
All right. Thank you, Prof. I think that's a lot to unpack, and also I think I have a lot of questions. But definitely for all the people who are interested to ask questions as well, you can either drop in the Q&A or the chat box, and also you can raise your hand, and then I'll pass to Yoga for you to facilitate that session. But for now, maybe on the first question, I think one of the things that you mentioned, like there are three things. Extreme events are occurring more frequent and at higher intensity, but we still have not much data in terms of long-term monitoring. But definitely at the same time, we do have like global data set. How do you think that this global data set, is it okay for us to use it to make like for local decision making, more like localized area? And also, is there any data sets that is mature enough, either in Malaysia or also Southeast Asian waters, that can be used to inform decision making, well, for like policy making or even for like disaster risk management and also like for financial type of investment? So,
Okay, I think there's two things we need to understand when we talk about data. There's if you ocean data at global level, we have abundance of data sets. So, and these data sets helps you a lot. But the problem with many countries is localized data. So usually global data sets provide you with understanding and perspective. But what prepares you better is a localized data sets. Take for example, I can have various kind of data products for surface wave. We can have like back 100 years back. We can have some historical data sets 30 years back. We have can have some prediction or even forecast data for wave. But as long as you don't have a good amounts of data sets at localized level, means that maybe 10 meters or 1 kilometers in the coastal area, in a very, in your hotspots of erosions. So nothing much that you can do because sometimes as the wave reaching your coastal area, the behavior is different. How it affects the coastal area at different sites is different. So we are still lacking in that in those aspects of localized data sets. Buoy system, for example. I'm sorry to say that in Malaysia, because we are not exposed to open ocean. So because Indian Ocean is a bit far, Pacific Ocean is a bit far. So our marginal seas is basically we don't have much. Not much. I think we can count how many coastal data that we have from buoy, for example. So because all of this deployment in the coastal in the localized area will give you real important information that global data cannot capture, because the global data only captures at certain resolution, so they cannot provide you with a very detailed resolution for specific sites in your country. So I think this is the clear I think some weaknesses that we are having in our when we talk about ocean and data for understanding the risk and resilience.
So I guess like from that answer, I would say that we do not have like for localized data, at least in Southeast Asia, we do not have a matured data in a way to make like this decision. So then perhaps like what is your suggestion in terms of like the urgent gap either in data methodology or even like infrastructure and some institutional coordination that we need to address in the next 2 years, because obviously people are already like sort of ready for this financial or like blue finance in terms of like coastlines and things like that. But if we do not have that data, how or like what are the urgency in terms of like the things that needs to be done if we have like in a short term kind of things, if the data we can't like sort of we can't go back 10 years in time and then plant some
Yeah.
sensors for that. So what would your suggestion be, maybe from a scientific view and also to link with the policymakers?
So what I think initiative is one thing. I see lots of I think in terms of marine communities, especially scientists, looking at other countries. Usually it started with local initiatives within either marine groups or some government agencies. Usually you look at some hotspots, area where you think that vulnerabilities is quite high. The risk is very high. So you pick up one spot, there's an initiative, maybe getting some funds to deploy basic data sets can provide you with a lots of input and informations. I think we try to doing it now in Terengganu, in our place in INOS. We deploy a basic temperature sensors, tide gauge, and weather stations in one particular site. So at least this initiative will set an example of how easy to set up a site for data collection, so that it will provide more inputs to the future if there's any issue with in your coastal area. So I would say that this sometimes goes based on local initiatives, and networks is also important. I believe that some of this data collection is become uh, is growing. So it's important for you to really understand what is happening in other sites and other places, either in your country or your neighboring country. So you can set a network, so you have a collective data set. So I think this is something that we are actually trying to work out continuously to make sure that we have a culture of data collection and making it works for a very long time. So the problem is some area we develop a new site for data collection, but it only runs until the project ends. So because the basic requirement is funding. When you don't have fund, so basically you just stop. So we try when you have a good network, good setup of initiatives. So maybe we hope that we can have a very simple setup, but can be continuous for a long time.
Yeah, like so definitely then like pilot sites and continuity is like one of the very important things. So I guess Yoga, I'll pass to you for the questions from audiences. Yeah, for you to ask Professor.
Yes, thank you, Khaira. So Prof. Fadzil, thank you for your insightful presentation. I will read some questions from the audience here in the chat box. The first question about relation between economic valuation and disaster data. So it's question from Ibu Pratita from Tanjung Pura University, Indonesia. What variables should we should observe when someone runs the model for elements of risk, hazard, and vulnerability? So for someone who's specialist in marine economics, she asked about what is the justification, for example, 50% or above 65%, depending on in the economic loss for the probability of damage it's occurring, or is it require someone who is an expert in ecology, Prof?
Yeah. Okay. I can answer the number one. Basically, nowadays models are being designed for a very specific purpose. So if you, let's say, you're doing focusing on the physical aspect of it, so you need to know what's you planning to have in terms of the data outputs. So before you start, you know what's you're gonna get from the data output. So for physical, for example, you want to look at the temperature increase or any ocean dynamics circulation changes that will affect productivity, that will affect fisheries. Sometimes if you really look into ecology, so it might require you to run biogeochemistry modeling, looking specifically into nutrients distribution and so on. So there's no one size fits all in terms of numerical models. So you really need to know what you plan to capture at the end of the outputs of the models. So I think that's number one. But your second question, I'm not sure. I'm not the expert, so I don't have. I cannot tell you what's justification value for what you call the damage or economic loss. So I can answer that. But in terms of the modeling, yes, there's a lots of actually. For your information, there's a lots of we call it a model data product. There's a lots of modeling data products out there, but mostly run at global level. What national, if you have a national interest about this, usually they do what they call it downscaling. So downscaling can put some higher resolution, but it requires some work, some expert. But you can talk to some of the experts that produce the global models to develop a downscaling that might have a better resolution for your country at specific sites. So this is the things that you can do, because if you look at the global level, there's a lot of types of models. It depends on what kind of output that you want. So that's the most important thing. You need to ask yourself what you require from those models.
Thank you, Prof. May I take another one from Kilin Salabi? It's really related with the last earthquake happened in southern Philippines. So the question is, can data like warnings and wave heights of tsunami be used in blue finance or financial planning on for disaster and ocean accounts, obviously? And or would it just stay as disaster information? How can we use this kind of data to inform finance?
Yeah, I think tsunami might be one of the natural disaster that up until now it is still something that is unpredictable. There's lots of I cannot say predictable, but at least you can have some forecast about it. Take for example coral bleaching, so you can make some forecast on marine heat waves or heat in because of El Nino, so you can have some a bits of prediction on how you're going to deal with it. But tsunami is something that same like earthquake. So something just happened and you cannot really do a prediction. But still, the impact of tsunami can be consideration in terms of risk assessment. Certain area is being exposed to tectonic plates. There is a Ring of Fire, for example. I think Kilin here is from Mindanao. So the hometown is affected by tsunami last time. So yeah, I mean certain area now becoming even a important components in evaluation of risk assessment, because especially now in our region the tectonic plates become, I'm not a geologist, but it is much more active than before. So it became something that will be a very important consideration in when you do the risk assessment.
Thank you, Prof. Maybe another follow-up question from that. You discussed a lot about physical data and forecasting through oceanographic modeling and physical modeling, while probably that also significance is social data and for in the community itself that will be potentially impacted by the disaster. So if I can remember, my thesis during my master is on social vulnerability index. So the condition in the social and the communities will affect how they can rebound from the disaster. And my question would be, based on your experience and works in disaster, how you integrate this the social data and also with the physical observation oceanographic data to inform the planning.
Yeah, I think this is where I believe that it is a responsibility to us to, making sense of what we understand from data, especially hazard data. Otherwise, if we don't looking into the perspective of the social aspect of it, it just end up becoming only a understanding on what is happening, but what is going to affect that by the data is we don't have really understand about it. So I think I just give you some perspective. It's good. Nowadays, there's lots of emphasis on SVI, CVI. So most of these vulnerability index is looking into communities and who's being affected by this kind of vulnerabilities. But it only happens maybe, I think that I should say still good. It only happens because of some requirement in doing certain projects, government requirements. But it is not a practice yet in among our scientists to, because I don't know, maybe scientists are very busy doing their science. So it's time for us to, once in a while merge between social science and marine science. So to look at how we can really work together and find the continuity of those understanding and looking into, straight into the social aspect of it and coastal communities. I think that is vital. Otherwise, we still could not resolve the issue that we are facing nowadays. I remember last time, long time ago, I was giving talk into a huge event on coastal erosion. In our country. So it's a like 2 days event. There's lots of experts and industries, presenting and everything. But there's no mention about communities. There's not even a one person who speaks about how this really affecting the communities. So I think that's and I did raise this issue, and suddenly everybody's realized that really, I mean, we should have thought about that, because we are so into our science and technicalities about the coastal erosion. We forgot that the extent of it, everything is happens, and we are concerned should be towards the who are affected by this coastal erosion, which is the communities. So I think the way we think about it should be changed. The way we work, maybe we should always have, especially scientists, cross transdisciplinary, so that we can really appreciate what we are doing by looking at how we can extend those research into a much impactful way towards the community.
Thank you, Prof. Another question from the audience. It's you mentioned that the universities are vital to producing the data for the predicting or forecasting risk and also hazard. But sometimes this data cannot find their way into planning or financial planning, to be exact, for disaster, and how what would need to change to make that this data is more accessible for user and for policymakers or financial planners. And you mentioned that scientists needs to find a way to wrap the data into a format that readable for policymakers.
Yeah. Okay. There's. I should touch on two things. One is data management. I've been talking about lots of aspect of data management before. I'm not the expert, but somehow staying in an institute of oceanography and having an institution that has lots of ocean data. So we put lots of effort in developing our own marine portal database. And it became actually after 10 years slowly developing and progressing in terms of collecting data. At national level, we just thought about having a national open science platform for one of the responsibility and roles is to actually compile all of the scientific data. But we've done much earlier because we believe that I think before you're talking about how you're going to use the data in a better way, you need to have a proper data sets, and proper data sets require data management. I think we are part of the Teacher Global Academy that focusing on ocean data management. I think once in a while, every year there's a short courses conducted by OTGA. Any one of you interested into data management, there's a free open course developed by OTGA. Last time they have it physically. Sometimes they can sponsor you to come from all over the place to Malaysia or their regional center. But nowadays mostly online. I think that is one important thing. Whether you come from, I think at regional level, there's two things. Either we don't have proper data management, or we have too many data sets that being managed by various agencies that you having trouble to to collect them into one single piece. And then of course, I think we have a very powerful tools nowadays, which is AI. I think this is the best way on how you're going to make your data presentable. Presentable means not only it looks nice, but it brings meaning into it. So I believe that all of you can make your data presentable by asking AI to do it, make it nice. All the graphic is superb and nice. But what I meant was make that interesting graphics meaningful by understanding the context of the relevance context of what you're speaking about, and the relevance data might be useful to the topics that you are talking about to specific agencies or specific people. So I think this require sets of skills that you need to develop. I believe that if I'm speaking to marine scientists or scientists in front of me, I would recommend you to have these two skills. Skill of using AI to produce a good visualization and presentable data presentation. And of course, how to bring meanings into that presentation when we talk about ocean data and relate it to the important things that you want to make sure capture those people who you speak to. All right.
Thank you so much, Prof. Unfortunately, we have come close to our session. So allow me to put some reflection and from our session here. First one that I got from your insight is there is a growing interest to data on ESG, environmental, social, and governance. in marine science. And also the second one, it's the social data, and especially the local data is currently underrepresented. So you need more network and new initiative in local to gather those data to inform and make a better decisions on disaster risk. This is where ocean accounting also comes. So you can represent, or you can display the data in the structured manner that readable to policymakers and also financial planners. And moving forward, it is need change of mind from and to more to interdisciplinary manners between social and marine science to produce the data that can speak and translate it into financial planning, and also to minimize and to reduce our risk to disaster in the coastal area. So with that, allow me to share more information on the Regional Dialogue webpage. If you are keen to learn about our Regional Dialogue sessions, the next regional session, and also the past sessions. And there's all the materials that we produce or talk, it's on these QR codes. And for this, I encourage you also to fill in the survey. So this is where we take your interest to how to make these future sessions more beneficial for us and for you especially, and how we can translate from these dialogues into more actions in the regional. So with that, I will close this session. Thank you very much, Prof. Fadzil, for guiding us through your insights and providing insights on ocean forecasting and data for disaster. Dr. Khaira for facilitating us for this session. And thank you so much for the participants for their engagement and questions. Thank you. Bye-bye.